To have our 20th annual physics demonstration show done by our stockroom staff. We have Doug Johnson, Sal Moreno is just coming in, Hector Maciel, and Maria Vaughn. And I can truly say that the very best part of teaching in this department is having this incredibly wide range of excellent demos that are so efficiently managed, and so we're going to get to see a little bit of that today. So I will turn it over to them.
Okay, well, thank you very much for coming. We've selected about 30 different demonstrations to show you. We may not be able to get to them all, but we'll try to get to all the fun ones. Okay. We like to usually start our lecture demos with electrostatics because they're the hardest to use in a lecture hall when there's moisture in the air. And the more people in here, the more reading that we do, the more moisture we'll have. So we'll do those first. And Hector's going to start off first with a Pepsi can.
Yeah. So I have the Pepsi can. Since the campus is all Pepsi, so I decided to show one of these. You can get a whole bunch of do physics with common stuff like the PVC pipe and can. And then you just I'm gonna rub this right here. Put some charge on it and see if it's enough to roll this can. Oh, there we go. Yeah. All right, slowly. Maybe put some more. So as you can see, you can get it to roll pretty easily with just a simple PVC pipe and some paper towel.
So we did that, and I'm going to charge by induction our popcorn cans here. So I'm going to charge up my board here. Let's see if okay, well that one's not working because it's kind of static, or it's too humid in here. So we'll try our Randy graphs. So they got me twin Vandy graphs since I have my twins here. And so, got humid in here.
Good.
So that's our popcorn machine. And then we got,
I should mention this is the first time ever we've done this demonstration with two Vandy graphs. And with the wig idea came from Sal. It says, what will happen if you have two wigs that are charged the same charge? Will they attract to each other? Will they repel? So we'll see the results.
yeah, I don't know if you guys have seen the wig before, but so this is two wigs. You can see the inside
I'll rotate it so
pairs.
there's a big gap between the two Vandy graphs. Last 6 weeks. Yeah, I got one more thing that we could do with the Vandy graph, and we'll try that right now. I can do it with several machines, and the Vandy graph's a good one. What I'm going to do is charge up this capacitor here. I'm going to use this platform here as an insulating base. And we're going to learn a little bit about electrostatics. We're going to turn off one of the Vandy graphs. Turn off one of the graphs. So what I'm going to do is I'm going to ground this through my body, this side of the capacitor, and then I'm going to charge the center core of this. This is called a dissectable light absorber. So we'll go ahead and charge it up. And then pull it away. Then if energy is stored in there, then we should be able to get it to come out. Okay. That's quite a spark, isn't it? But we're going to show another characteristic of a capacitor in the process of this. Okay, where's the charge stored is a question. So we'll take this thing apart. Okay, and I'm going to touch the two metal parts. Okay, I'm not going to touch it, but here we go. Okay, I didn't see any spark, did you? The charger's actually pinned on the inside and outside of this. Okay, so we'll put it back together. This is where physics is magic, hopefully. Okay, so that shows the charge was on the inside of there. Okay, so that was now a lot of us have seen generators, static generators. This is one over here. It's called a Wimser's. As soon as that gets moved out of the way, I'll push it to the center. And we'll talk about it a little bit. The reason why I like to show this particular one, it puts off a pretty big spark. And where does all the charge come from? I took the liberty to grab a regular hand crank generator. This is one way we can, there we go. So that's how we generate electricity. You have magnets, you have wires going around in the magnetic field generating electricity. That's how we normally do it. Electrostatic's different. In fact, we're going to see if we charge this thing up and see what kind of spark we can get off of it. Let's see, that should be pretty good. As these plates roll around, we start charging these light jars on each end. And it's a kind of a complex machine, but you can see that it's taking on a charge, storing in the capacitor. The thing I should warn the faculty about, and this is part of the reason why we have these shows, is not to run this thing too fast. We tend to want to run it fast, and what happens is the plates wobble, and these metal combs here have little points on it, and will knock off all the metal plates on it. So it's good to run it slow. You shouldn't have to worry about it. Okay, so a lot of repair work to get it fixed. So what I'm going to do is I'm going to ignite this flame here. And I'm going to charge up the plate. And because the plasma in the flame has a negative charge to it, it's going to be repelled towards the plate. Okay, so I guess I have to move this out. You'll see that flame will start bending towards. I'll rotate it around so you see it.
Rotate a little bit more.
So usually you do this between two plates, but I figured it was easier to show everyone that you have just one point. Okay, I think that's about it. What's up next? Oh, okay, one more. We have this device called Jacob's Ladder. I love this particular one, but it's not used very often. So this thing is a sine transformer that goes up to 10,000 volts. So you don't want to touch it. Okay, so it's very important we make sure it's not plugged in, for example. Okay, the gap has to be right. Looks like it's changed since we've transported it. But 10,000 volts can jump a half-inch gap pretty easily. Okay, depending on the moisture in the air. And I'm going to put this cover on it. so that air currents in the room don't disturb the device. And we're going to turn on this transformer here, going to boost up the energy, and hopefully it will bridge the gap. There we go. Someone turn off the lights back there? Ah. Okay, we have it a little bit too far. Let me turn this off. This is something we like to use during Halloween, so it looks a little bit mysterious. So why does it bridge the gap as it goes up? There you go, now it's self-starting. The air, as it heats up, becomes less resistant, and so that it can bridge the gap as it goes further up. You can put a piece of paper between it, it'll poke little holes through the paper, actually burn holes in the paper. So, anyway, I don't see that used too often, but it's a fun little demonstration. Okay, and so there's 10,000 volts there, so you got to make sure you're unplugged before you transport it. Okay, so Hector, you got?
Yeah, I want to show this properties of diamagnetic and paramagnetic of certain materials.
You want to use the overhead?
Overhead is sort of in the corner over there.
Get it. Turn it on.
Yeah, I don't know if it's,
Well,
oh yeah,
you
now,
either-
now. And this demo is just to show the properties of materials. I have carbon, black, and then these are, I think, aluminum. The blue one is sulfate.
Copper sulfate.
So at the end of this little stick, I have a needle magnet, and they generally are pretty strong. So whenever you handle these, just be careful. So let's just stabilize this somewhere.
If you're overdrawing your credit card, can I borrow that?
Yeah, you can just erase it. So right here. You see how it's attracting it? Let's try this side. Pulls it back. See, I'm not touching it. It's just the attraction of the material and the magnet.
That's lamp black.
Yeah. And that's carbon. Let's see if this one. This one is also attractive. So this is just to show the properties of the. So it's a nice little demo to show.
Let's try some water.
Water? Yeah, we have water. What are the properties of water? So you can play around with this and show. Not that you get it stable first. So that's a repulsion. So with water you get repulsion. Opposed to carbon, you get attraction. That's the demo.
There's sulfur, aluminum chips, and all sorts of different materials that you can also show this.
Yeah.
Very good. Thank you, Hector. Okay, let's turn on the lights. Okay, what's next? Are you getting the high voltage? Oh, okay. When I started here at Cal Poly, that was 30 plus years ago, one of the most fun demonstrations I remember is this one. So I thought for the 20th anniversary that we do this. Now we have a very strong World War II magnet here. And if you get too close to this with your credit cards and stuff, it can get wiped out. We used to have problems when you go through the stockroom with it, all the monitors would start twisting and turning on us as we were watching. You've got a storage battery, and just a regular copper wire going through here with some insulation on it. And to show that this is a magnet, you got a little paper clip here to show there's some magnetic pole. This happens to be North Pole, South Pole. And if you use the right-hand rule, and you have the current going the right direction, it should either jump up or go down. So let's see what we have here. And the effect is a lot more than I expected the first time I saw this, so I thought it'd be kind of fun. There's nothing going on. Oh, there it is. So that's called the jumping wire. So if I reverse, I could reverse the poles of the magnet, which is not impossible to do. I can rotate. In fact, let's do that. And we'll see the opposite effect take place. And of course, Faraday noticed this a long time ago when he had electric current and a compass right next to it, and he saw that the compass was deflecting, and that was quite a discovery back then. So let me lift this up a little bit. See that it's definitely pulled downward. So that's the jumping wire. Any other things? I think that's it. Okay, Tesla coil. That's the one I've been waiting for. Not too many people like to use this particular device because it's a little noisy and a little scary. One of the faculty used it in one of our smart classrooms, and they took out the projection system. So we recommend you be mindful of the speakers, the projector, and the computer. Try to put it somewhere that won't be affecting it. Okay, and all this is a primary coil and transformer, real high amount of turns on the secondary, and there's a circuit in here that causes it to break, open and close, so these fields are always constantly expanding and contracting. That's what creates the high voltage. So we'll go ahead and plug this thing in and turn this thing on and see why everyone's so afraid of it. Go ahead and turn off the lights again. Now, of course, it's perfectly safe if you know what you're doing with it, but even when you know what you're doing with it, sometimes it can shock you. So we try to prevent that. And I'm grounding out the other side of this tube to the base, so hopefully I'll be able to light this remotely. Now, Tesla thought this would be a good way to transport energy to homes and businesses and stuff, but it was never fully adopted. Probably a little bit impractical. So, for many reasons. But anyway, just to show that. And then one of my favorite things to do is, leave that there. And this is a neon tube. And you can see that that's a little bit more sensitive. And you go pretty far away from the source and be able to get the current flow through that gap. And you can size the gas and cause it to flow. I don't want to get too close. Okay, so that's the testing point.
I can also show my phone. I have a wireless charging on it.
Okay.
While they set up that one, I'm going to show a little app on the phone. I don't know if you guys have ever, most of you guys know what quantum mechanics is, right? So there's a little app they made just to make it more easier to visualize the orbitals, the eigenfunctions. So let me just show that quick little app. I'm gonna lower the, so it's a little hard to sometimes visualize these orbitals. But with the help of this app, it's really neat. So this is n equals 3, 2. So you can grab it and spin it, and it shows, you know, on the bottom it has a function. Then you can just tap it, it gives you the distribution. You can tap it again, it can give you the energy state, I think. So it's just a nice little app to show you, for if you want to explain a little bit to friends or relatives.
What's the app again?
It's called Atom in a Box, and it's available for your iPhone or iPad. And I'm not getting commission on this, so I just
Go ahead, turn on the lights there. Raise up this screen. Okay, so let's see what we got. This is what we call the ping pong atmosphere. This goes to show. Okay, well, we get the ball down to this end. It's going to go this way. There you go. Okay.
No, I have to ask, is our new dean at the safe end or the?
Well, if you know my history, you would be ducking for cover. Okay. Let's see if we can get this seal off. What we're going to do is we're going to evacuate this tube. We have some seals on each end, so if the seals hold and hold back the atmospheric pressure, we will be able to launch the ping pong ball through this tube into those cans over there. And so now, and this is one of those awkward experiments because you can't transport it very easily. And so it's, so we put this on the last minute, and it takes a little time to do it. So I think if everything's going well, we'll go ahead and pull that atmosphere out. Plug in first. Okay, looks like we got it. We've, at different universities, measured the speed of the waters at excess, and we found it's around 300 miles per hour. When you think about that ball that's being transported down the tube, breaking the seal, and then it's going to go probably through the first can, and embed itself in the second can, but sometimes it goes through the second can too, so we have a third can go just like that. Okay? And this will happen very quickly. It's loud, so you can cover your ears. Okay, I'll need something for you. Ready? 1, 2, and... Wow, it really did the number on that ball. The ball actually broke in half. So anyway, that's the atmosphere gun, and it's amazing how much pressure the atmosphere has around us, especially when you remove it, you put it in something. Zero calories. We go through a lot of ping pong balls. We'll go ahead and pass this around for people to take a look at. I don't know, do we have a video of this?
We don't because it actually, did we get it? It's a high speed? Harvey Mudd has something similar.
high speed one.
You don't really see it on the regular camera. You I mean, you can video it, but then you won't see the ping pong crashing.
Yeah.
So if we get a high-speed camera,
That would be nice.
then you can video the whole thing.
Here we have a demo called collapsing the cam by steam. It's basically taking into account that we're using heat to change the volume here, and then we're cooling it down with water and decreasing the pressure to collapse it. So we can see the atmospheric pressure.
Is he home?
There we have the steam. And here we have the collapse.
Takes a little bit longer, you can do that behind too.
They have on YouTube a video of not video, just a still picture of one of these tanker cars on a railroad. That had been collapsed by steam. They cleaned it out with steam and they capped it off, and then of course, so it's something that you should be aware of.
Here, this is called Bernoulli's tube. This shows the atmosphere. You can have moving air change to be lighter than regular atmosphere by just putting it across the top. So we have our, our lung capacity really good. Bradley, I want you to come volunteer. See how well the, just blow across the top. Yeah, don't. Can't see it. Stay on this side, just blow across the top this way. Okay, the trick is a little upward. Yeah.
I wanted to show something. For those of you that have low lung capacity, there's always a backup plan in the physics department. So if you have a little blow dryer, you can play with it. But anyway, the backup plan is that, I don't know how far back you go with this. Anyway, this takes very little force to, with an air pressure difference in order to use that.
What's your plunger on that?
I'm sorry?
What's your plunger
It's
in
a
that?
piece of styrofoam
Yeah, just a piece of
with the
And,
packing
uh,
that's layered.
This was an original from Cal Poly. This is one I developed 20 years ago. And it came from a practical application. I was working as a mechanic and a line mechanic. We had someone dump a bunch of soda cans down a pipe. And they wanted me to get it out of the pipe. And so I used the air hose, and that's how I retrieved them out of the pipe. So I had to make a demonstration from them. Okay. Now, I did some improvements on the vortex gun. Maria, I'm going to have you hold the target, okay? And I was been trying to put a little bit more, so there'd be a little bit more accuracy with it. I had a laser in it and all sorts of, but I found that it's just almost as easy just to lean it up against yourself. There we go. Okay. Here. And if you want to have a good target, you know, this styrofoam cups are really great. So you can have your pleasure of whatever you want to do here. Okay, here we go. Okay, so, and this could be done pretty far back. Oh, come on, make me laugh. It's working pretty good. The improvement was the rubber band inside, and then you don't have to beat the drum anymore in order to get it together. So I think that works pretty good. Also, I won't show it, but you can also blow out a candle from pretty far away. We do have a smoke machine if you want to show smoke rings, which is really nice, but we won't do it right now because we're in such a confined room. So that's it for the vortex camera.
Well, I have a smaller bag here. Well, not small. I asked him to put it more. Do you think I can blow this using, going like this? And then, as you can see, it will take forever for me to blow it up. But would you believe me if I told you I can do it with one breath of air? Well, for those non-believers, let me guys show you how to do it. Place it right here. Let me see if I have the line.
We have a demo here called the howitzer and tunnel. And a howitzer is actually a cannon of some sort, right? And the story is that as a train is going through a tunnel, before the train goes through the tunnel, they shoot this cannonball straight up in the air. And then when they come through outside the other end of the tunnel, they get hit by their own cannonball. Okay? So anyway, we had to duplicate that. And hopefully we got, looks like it's running pretty well. We'll go ahead and cock the gun. For instructors in here, make sure you use the block. Okay? And on here, the cannonball is a lead ball. Okay? And I use lead because it doesn't deflect or bounce off the rim of this as much as the other metals. Okay, cock the gun. So what's going to happen is when this thing is sent down the rail, the pin will pull and the ball will jump. And it will go over the top of the tunnel and will land back in the cup. Now how many think that will happen? Yeah, okay, you guys have been taking some physics, good. Okay, so we'll prove this is true. So go ahead and push this down. There we go. 1, 2, and 3. That tunnel is kind of uphill tunnel. Will we have the same effect? Or will they escape, or will it hit behind them or in front of them? So let's give this another go and see what happens. Let's see. Again. Okay, so how many think it's going to fall behind the cart? Raise your hand. How many think it's going to fall in front of the cart? Raise your hand. How many think it will just land right back in the cart? Okay, there's a few of you who are undecided. That's okay. Let's see what happens. Actually worked better, didn't it? Okay, now so the question comes again, what if it's downhill? Well, things change. Of course, as you go uphill, there's a uniform deceleration. You go downhill, there's an acceleration for the cart, but will it match the angle which the ball is down? So try this once again. It's down here. Okay. more try. Hope it's 3 for 3. Okay. So we done?
Yes.
You good? Okay.
Now, the monkey gun, the large monkey gun, or the funnest and most enjoyable one. Basically, it's just to show things accelerate at the same rate. So if there was no gravity, the monkey would stay there and this would hit him right there. But because we have gravity, both things are going to fall at the same, accelerate down at the same rate. I think we lost. Temporary loss.
Another ball?
Yes, I do. Yes, I do.
You wanna do the hat or just?
I can try that.
Now, this is your skill level, you know, if you hit the hat, you're really good. I think we should try to miss the computer. Maria, you may want to send us very good. We're going to do what we call a faith painting, okay, or the bowling ball of death. It depends what you want to call it. Some people call it a melon basher because they put a melon next to it when it swings back and forth. But or nose basher, I've heard that called that too. But whatever it is, we just got to be careful that we do it in a way that no one will get hurt, because we don't want anyone to get hurt with these demonstrations. Now, Hector here graduated from Cal Poly. He has a lot of faith in physics. And so we're going to have him as being the guinea pig for this. And he trusts me, which is really nice. Okay, let's find out how far we need to set this. Bring your closer. Back a little bit. Okay, so what we're going to do, we'll bring this up to his chin. So we're going to call it chin basher. Okay. Now, he can't lean forward. That's why we have the stand here. And what we're going to do is we're going to set this thing in motion. Hopefully the roof will hold the weight of the bowling ball. And as it comes back, we know that there's not going to be as much energy as when it was released, right? So it always falls short of the target. Well, that's if I don't push it a little bit. So I'm not going to push it. We're just going to hold it straight, let it go, and don't lean forward, Hector. There were rooms on campus that we could use this, so we thought we'd take advantage of showing it in this room. Let me just go further out right here.
Okay, this is kind of scary for me because we're using live eggs. Well, not live eggs, well, eggs uncooked eggs, raw eggs. So, we're going to hope that I hit it properly, and objects at rest want to stay at rest, so I'm not going to go to it.
Alright, so I have two balls, another ball right here, and these are just to show the reaction. So if I let go this one, bounces, Like go this one, doesn't bounce that much. So, but if we combine them and see what happens, see what that one bounces. That's what you got to do. I don't know if you guys play basketball here, but if you go into a basketball court where it's not as nice and clean to play, one question that I have, if you bounce the ball clockwise like this, is it gonna bounce counterclockwise or clockwise? Huh? Clockwise? Counterclockwise?
I think counter.
All right, you think, so it's a little tricky to do, but I think I got the technique. Yeah.
Very good.
And the same thing happens if you throw the ball, so you're gonna throw it somewhere, and you spin it, come back. So it's just a nice little, good example of, physics.
During the summer, we had a technician meeting. We do this twice a year, in which we meet with other technicians in Southern California. And one of the teachers, we had a high school teacher there, he showed us this demonstration. What we're going to do is show in a physical way transfer energy from one tuning box to another. If they're exactly the same frequency, and I mean right dead on, you can get a transfer of energy. And usually you hear, like with this box here, you'll hear the tone, and then when you turn this off, you'll hear the tone of the other one. And in a large lecture hall, that's kind of difficult, okay, to hear that tone. So we came up with this modification, which the ping pong ball is resting up against the tuning fork, a little bit more in the center. And if it resonates with it, you'll see that ball, our ping pong ball, start bouncing. So here we go.
Constructive interference.
Animals. I worked a long time to get that to work.
I'm gonna do the rocket. Right. It's just the, is it clear? Am I clear? So bring me the little bottle with you want to try this at home?
Is that going to be high there?
Where else?
Maybe I can hold it. I can hold it.
You want to hold it on that end?
This,
Okay.
you're going to send it this direction towards me.
Yeah.
I can do that, in fact.
All right, so this is going to be our fuel right here. So we want to put a little bit of fuel. So a little bit more. Let's see if we can propel it. Shake it a little bit. Alright, so
Really don't want you doing this at home.
How about the classroom roofer?
Got it?
you guys ready?
Let me turn off the lights before you. Okay, here.
Whoa.
you how satellites work in the atmosphere. All right, so I'll need my handy dandy volunteer. Okay, now step on the platform, careful not to fall. Okay. I want you to hold that, like that. Okay, I'm going to spin them. Okay, so I want you to turn your hands so you turn the wheel like that. Now go the other way. It turns you back. Well, here, I'll make it go faster this way. Have your weights for you. Alright, so grab a weight in each hand. So everyone's seen ice skating shows?
Oh, yes.
So hold your hands out. Okay. Now bring your hands in. Out first. Bring them slowly in. Now, everyone, slow down there. That's cool. Okay, out.
How does this work?
You know, I don't know. I suppose you could try the Guinness World Book of Records.
How good is the bearing?
Thank you very much.
Okay, all done then?
Yeah.
We're having to do some editing, last minute editing, because we're running out of time. We're going to do a anchor breaking demo. I did this last year and probably the year before, but every time everyone seems to like it. So then we're going to take amplified sound. And once again, like the tuning course, it has to be at exactly the right frequency. If you're off half that hertz, it won't work. So it's got to be within 1% of the actual frequency, resonant frequency. So right now we've taken this beaker here and we've calibrated it. We have a calibration number on there for the frequency. And this particular amplifier, whenever you turn it off and on, it goes to 0 or 1,000 hertz. And so we have to plan for it. And so we'll watch what's going on the oscilloscope, and many of you won't be able to see that. But as it hits the right frequency, the height of that pulse will get taller, okay? And you want to find out where the peak of that is before you turn up the volume. When you turn up the volume, we'll hit the elastic limit of the beaker, and it will shatter. Okay, so if everything goes well, we should see this shatter shortly. Okay, let's see. Hit the right frequency. And go down, 98.8. I tried earlier because there's some temperature change. Okay, we're going to turn it down some. Now if I go on either side, I don't want everyone to see this, but if you go on either side of the frequency, you'll see it will diminish. And you go too high, it'll diminish. So you really want it right on top of that resonant curve there. Okay, so now, see if I can keep from getting into the picture here. I will turn up the volume, and we should see that big shatter. Okay, count of 3. 1, 2, and... Every once in a while we get a flaw in the beaker and it doesn't work, so we always have a backup beaker in case this doesn't work. Anyway, this time it worked.
So our next demo is, this one was, I guess invented or done here first. So If you see it anywhere else, it's probably a replica of this. This is a similar demo like the Hero's engine. The Hero's engine is, it's a container, and you put a hot steam in it, and then there's some little vents on the top, and the vents releasing the hot gas through the vents and makes it turn. So this is a similar one. It has little vents on the top, and we put liquid nitrogen, and we just submerge it in the water and see what's the difference. I like this one better. I hope you guys do. Last one.
Oh, it's me.
Okay, this is going to be our last demonstration for the evening, or the afternoon. We haven't used this demonstration for a long time, at least over 20 years, honestly. And the reason is we just don't like it. I don't. But because it was requested, we're showing. Okay, so keep those requests coming in. We have a volunteer. The professor that requested it is who's going to. No, I'm just teasing. Okay, but we're going to have our soccer and healthcare Sal is going to lay down on it. He has to do it very carefully. Go ahead and start from this one. You want that up? Yeah. Well, you have to practice this before you do this experiment. Okay. Of course, if there's only one nail there, we would have a problem, right? So because there's many nails there, the points of pressure will be evenly distributed over the back.
That's your new shirt you bought?
You decided if you're going to get blood on a shirt, it's going to be a cow polish. We have the other part of the demonstration very much.
All right.
Yeah, I give a little warning. I'm going to turn it this way. Okay. I can't.
It's above your pay grade?
How's that feel? Feels good. Okay. That's what he said. I heard him. Okay. Now, Sal, we did agree on this. I did talk to you about sorry about that. I don't drop this too often, only after heavy objects. Now, if you had a choice for me to hit this, which one would you choose?
Definitely the tiny one.
Okay, here we go. We used to use a cinder block on the top of this. We'd hit it and it would split off, and it was quite dramatic, but we ended up with some injuries. So we're sparing it from that, but we're going to do something a little bit different. Are you still okay there, Sal? I know I'm taking my time on this. Okay. So we'll set up a little set of blocks here, and we'll drive it down through this piece of wood. So here we go. You ready, Sal?
Yes.
Here we go. 1, 2, and oh, I didn't go through yet. Oh. Get them off safely, then we'll. For those who want to see this other demonstration themselves,
Are you sure? I'm heavy.
okay.
You have your iPhone in your back pocket.
No, I make sure.
Okay, for those of you that are diehard and want to see do one more demonstration. Hector has one he wants to show you.
Yeah.
But it will be in the breezeway.
The relay, because there's some safety concerns. It's gonna be the gummy bear experiment. So I don't know if you guys seen it before. But I'll show it on the replay.
Yeah, if you want to. Anyway, thank you so much for coming. We look forward to doing it again.